Hello everyone, today we're going to divide radicals. So, this is just the continuation of my first video about dividing radicals. So today, we're going to make use of the process called rationalizing the denominator. We also used that in my first video about dividing radicals. So again, we're going to make use of rationalization. This is the process of removing the radical in the denominator. And also, we're going to make use here the conjugates or finding the product of the binomials of the form a plus square root of b and a minus square root of b. So, a and then b are rational numbers. A plus square root of b and then a minus square root of b are what we call conjugates or conjugate of one another. So, as you can see, we have here plus and then this one we have minus. Okay? Examples of conjugates are 5 plus square root of 3 and then its conjugate is 5 minus square root of 3. Another example is that if we have x minus square root of 2, so its conjugate is negative x plus square root of 2. Okay, so we have here the first term. We have here the second term. Okay, so next, another example, we have 2 square root of 5 minus 6 square root of 3. And then its conjugate is 2 square root of 5 plus 6 square root of 3. Okay, so let us now find the quotient or give the quotient, then simplify. So, number one example. Let's say we have square root of 18 plus square root of 32 divided by square root of 2. Okay, so if we're going to write it, we have square root of 18 plus square root of 32 divided by square root of 2. So, what are we going to do is, we're going to make use of the quotient rule for radicals. We have this one, square root of 18 over square root of 2 plus square root of 32 over square root of 2. Okay, so we have here square root of 18 over 2 plus square root of 32 over 2. Then, square root of 18 divided by 2. So, we have here 9, right? 18 divided by 2 is 9. Then, 32 divided by 2, we have 16. So, plus square root of 16. Now, we all know that the square root of 9 is 3. And then, plus square root of 16 is 4. So, the final answer here is 7. Okay? Next, number 2. Let's say we have 2 square root of 2 plus square root of 3 divided by square root of 6. So, let us rewrite this. We have 2 square root of 2 plus square root of 3 divided by square root of 6. So, notice that we cannot divide 2 and then 6. So, what are we going to do is, we're going to make use of rationalization. Okay. 2 square root of 2 plus square root of 3 over square root of 6. So, we're going to multiply both the numerator and then the denominator by square root of 6 over square root of 6. So, square root of 6 over square root of 6 is 1. So, it will not affect the original expression. The next is that, why is it that we multiply both the numerator and the denominator by square root of 6? Now, because if you're going to multiply 6 and then 6, that is 36, wherein 36 is a perfect square, right? So, we have to multiply 2 times 1, the coefficients, we have 2, then 2 and then 6, so we have square root of 12, then plus this one, 3 and then 6, okay? First, we multiply it by 2 square root of 2 times square root of 6. Then, next, we have to multiply it by square root of 3, okay? So, multiply the radicands. So, we have 18. All over, 6 times 6, that is 36. So, we have square root of 36. Then, as you can see, 12 is factorable and then 18 is factorable, right? Wherein, one of its factors is a perfect square. For 12, we have 4 and then 3, right? And then for 18, we have 9 and then 2. Okay, so we have 2 square root of factors. We have 4 times 3. Then plus square root of 18, 9 times 2. Over square root of 36, we have 6. Then next, we have 2 times square root of 4 is 2. Then you will just copy square root of 3 plus square root of 9 is 3. Then square root of 2 over 6. Okay? Then, let us now multiply. We have 2 times 2. We have 4 square root of 3 plus we have we have 3 square root of 2, okay, over 6. Okay, so this is the answer for number 2. So we have 4 square root of 3 plus 3 square root of 2 over 6. Number 3, let's say we have 5 divided by square root of 3 minus 2. So you have to enclose this in a parenthesis, because if you're not going to enclose that in a parenthesis, let's say we have 5 divided by square root of 3 minus 2, meaning to say you will just divide 5 by square root of 3, and then after that you will just minus, you will just subtract 2 from it. Okay, so going back to the example, we have 5 over square root of 3 minus 2. Now, what are you going to do is, you're going to multiply both the numerator and then the denominator by its conjugate. So, what is the conjugate of the denominator? We have square root of 3 plus 2. Okay, of course, over square root of 3 plus 2, because this is equal to 1 and it will not affect the original expression. So, we have to multiply 5 to multiply monomial to a binomial. So, 5 times square root of 3. So, of course, this is a whole number. So, you're going to multiply it here outside the radical. So, we have 5. Then, you will just copy square root of 3. Okay? Then, plus 5 times 2, we have 10. Then, over, of course, you're going to, as you can see, this is the first term, this is the second term, right? So, This is sum and difference of two terms. So let us have a review that if we have sum and difference of two terms, to get its product, you're going to square the first term minus square of the second term. Okay, so we have square root of 3 squared minus 2 squared. Okay, so we have here 5 square root of 3 plus 10 over square root of 3 squared is 3. Okay, so because this is equal to 3, the exponent 2 over the index 2. So this is equal to 3. Okay, 3 raised to 1 or 3. Okay. Then minus 2 squared is 4. Then equals to 5 square root of 3 plus 10 over 3 minus 4, that is negative 1. So simplifying this, we have 5 square root of 3 divided by 5 square root of 3 plus 10 divided by negative 1. So that is negative 5 square root of 3 minus 10. Because if we're going to write it, we have this is equal to 5 square root of 3 over negative 1. If we're going to divide that, that is negative 5 square root of 3. Then another one, we have 10. We have 10 over negative 1, that is negative 10. Okay. Okay, so this is the answer for number 3. Next, for number 4, we have 2 square root of 18 divided by 3 square root of 3 plus 2 square root of 2. Okay, so let us rewrite this. We have 2 square root of 18 over 3 square root of 3 plus 2 square root of 2. So again, we're going to get the conjugate. We have 2 square root of 18 over 3 square root of 3 plus 2 square root of 2. Multiply it by its conjugate. The conjugate of the denominator 3 square root of 3 plus 2 square root of 2 is 3 square root of 3 minus 2 square root of 2. Okay, over 3 square root of 3 minus 2 square root of 2. Okay, next, we have, again, we're going to multiply 2 square root of 18, okay, to the first term of the binomial. We have 3 square root of 3. So multiply the coefficients. So we have 2 times 3, we have 6. Then multiply the radicands. We have 18 times 3, that is 54. So square root of 54. Then minus this one. We have 2 times 2. So that is 4. Then 18 times 2. So that is 36. So square root of 36 over this one, the denominators. Okay. You get the first term. We have 3 square root of 3, square it, minus the second term, 2 square root of 2, squared. Okay, next. So we have 6 square root of 54 factors of 54, wherein one of its factors is a perfect square. So we have 9 and then 6, right? So 9 is a perfect square. Minus 4, square root of 36 is 6. So we multiply it by 6. over this one. 3 squared. So that is 9 times square root of 3 squared. We have the radicand itself, 3. Then minus 2 squared. We have 4. Then times square root of 2 squared. So that is the radicand itself. We have 2. Then this is equal to 6. Then square root of 9 is 3. Then square root of 6 minus 4 times 6, we have 24. Over 9 times 3, we have 27. Then 4 times 2, we have 8. So minus 8. Then let us multiply 6 times 3, we have 18. Square root of 6 minus 24 over 27 minus 8, we have 19. So this is the answer for number 4. Okay, so that's all for today. So for more videos and updates, please do like, comment, share, and click the notification button for more videos and updates. Thank you.